Hello, welcome to Keith's Pie Tutorials. I'm Keith Ellis. Today I'll be speaking about my 3D printer. I've got Tronxy X1. I was perfectly happy with it with the stock firmware, but after watching a few videos I discovered it didn't have the thermal runaway protection enabled, and I wanted to get that enabled. So the only way I could do that is to upgrade the firmware. Now, by default, the Tronxy, the Melzi board in the Tronxy doesn't have a bootloader. So I've investigated various ways of upgrading the firmware. So I'll show you in this video how to use a Arduino Uno as a programmer to upload the firmware onto the Melzi board. Then show you how to use the same Arduino Uno to burn the bootloader, and then I'll show you how to upgrade the firmware just using a USB lead straight to the back of the Melzi board. So I hope it's useful. Enjoy. Okay then, let's look at the setup here. I've taken the Melzi board out of the case. It just makes it easier to connect up the wires. I've still got the screen here. So I've just got the screen connected to here. And this is the ISP header, which is how we'll be programming the processor, or reflashing it. So this bit here looks a bit complicated, but this is essentially, this and this bit here is just an Arduino Uno, and that's what I'm going to be using as a programmer. I don't have a AVR ISP programmer, so it's possible to use an Arduino Uno as a programmer. Now it looks very complicated. If you take a look at shrimping.it, let me just pull that up. They tell you how to use, this is the Yamega 328 processor, which is essentially all an Arduino is, Arduino Uno, with a crystal capacitor on the reset line and a pull-up resistor, and you see that's all on an Arduino Uno's, but an Arduino Uno also has a USB controller, so you can plug it into a USB socket, and that's all this bit is. So that's how I plug that, and that is my Arduino Uno. So to prove that, I'm just going to upload the blink sketch. So the blink LED is on pin 13. That's not set up at the moment. Let me just plug an LED into pin 13. So that one there, and plug into pin 13, which is that one there. So we can see the I've got the pin out here. This is a 168, but the 328 is exactly the same. So this pin 1 is in this top left hand corner here, top corner. So pin 13, digital pin 13, is this pin here, which is going to be the screen LED. So if we go to the Arduino IDE, I've got, what is the blink? It's a blink sketch. This is just a bog standard blink sketch. LED equals 13, so we're going to put the LED to an output and flash it, turn it high and low. So let's plug this into the USB, and what I do now, so this is our Arduino Uno, so let's set this to Uno and set the port to my USB port, and upload it. Just keep an eye on that green LED, hopefully we'll see that. So it's compiling now, it's uploading, and you can see it's very faint. The green LED's flashing. So that's just the bog standard. That's an Arduino Uno. Taking the standard sketch. So what I'm going to do now is, if we go to the Arduino again, in examples, there's an Arduino ISP sketch. This one here, which I've got open. This is so this sketch here I'm going to upload to this Arduino, and it's going to act as an ISP programmer. So it tells you your pinouts here. I'm going to go through that in a minute. So let's, for now, let's just make sure that's set to Arduino Uno. You'll see sometimes the it doesn't change. So change it to something different. Put it back to Arduino Uno. This is USB port's correct, and let's upload that. So let's upload it now, and it's done. I'm just going to put this wire back here. I believe that was done there. Yeah. So what these LEDs are, the ISP sketch, these LEDs are optional, so it's just LEDs with a resistor connected to ground, and then three pins from the Arduino. So this one pin here is, if we have a look at the Arduino ISP sketch, pin 9, digital pin 9 is heartbeat, so it's just continually flashing. This is connected to pin 8, which is an error LED, and this is pin 7, which is the programming LED. So when we're communicating with the Melzi board, this will be flashing. If we get an error, this one will come on, and this is just a heartbeat to tell us it's all alive, and that will just continually be fading in and out as it is now. Right, so that's programmed as an ISP programmer, basically, just with an Arduino. Now, this looks a bit complicated here. If we had an Arduino Uno, this is a Mega here. I would have used this, but I couldn't get the ISP program to work for the Mega. So they come with this ISP header here, this 6-pin header, which is the same as the 6-pin header here. If we turn this board around like that, this pin out is identical to this. So if we have a look here, so this is drawn. This is the Melzi pin header here. So this bottom right hand one is MISO, which is master in, slave out. To the left, bottom left, we've got 5 volts. Then the second one up on the right is the clock. Then the one at the back right is reset. And then top left, you see me pointing here, the top left here is ground. And then the middle one on the left there is Mozzie, which is master out, slave in. And then we've got 5 volt, I think I've already said that, on the bottom left. So that pin out here is exactly the same as that pin out, which with the Arduino this way round is exactly the same as this pin out here. So when we're these, there's 1, 2, 3, 4, 5, 6 wires, so each of them pins are connected, with the exception of the reset pin. The clock, the MISO, the 5 volt, the Mozzie and the ground all connect wire for wire, as you see here. Arduino as a programmer, and the Melzi, so ground goes to ground, 5 volts goes to 5 volts, Mozzie goes to Mozzie, or you can use pin 11, it's equivalent. MISO goes to MISO, or you can use pin 12, it's equivalent. The clock goes to the clock, which is also pin 13. The only wire that doesn't go from the ISP header on the Arduino is pin 10, which goes to reset. So that's all I've done here. That's them 6 wires wired up. and the LEDs, which are optional. So what have we, just recap, what have we got here? So we've got our Melzi board with just the display connected. We've got the ISP header connected to our Arduino Uno. The Arduino Uno is programmed as a ISP programmer with the LEDs to tell us what's going on. And because we haven't got a USB chip here, we've got our USB chip here, which is through the interface to the Uno. Okay then, so let's have a look. I've already set up the, what I'm going to do now is upload Repetier host version 1.0.2 to my Melzi board. Now there is a bootloader on here, but using this header you don't need a bootloader. Originally this board didn't have a bootloader, and I did exactly this process, and you can upload your firmware to the processor without a bootloader. So if you've got a stock Tronxy, this is from the X1, and you haven't got a bootloader, then this is all you need to do to upload a new firmware. So I've got the Repetier host firmware, and I got this by using, there's a very good, on the Repetier website, if you go to repetier.com/firmware, you can get the configuration tool. So this is the tool for versions 1.0.2, which is the latest. If you've got if someone's given you a config.h file, you could upload it. You could just upload the config.h and it will import them settings. But if you don't, you can just work your way through here. This isn't what we're looking at here isn't the Tronxy setup. This is just the default. What I could do actually is if I upload my config.h, you can see my settings. So there we go. So these are the settings I'm using at the moment. So I've got a Melzi board, it's Cartesian. This is the port, 115200 baud rate. Got no Bluetooth. There's various positions. We've got the dimensions of the bed. We haven't got Z correction, so ignore that. So this is a really good wizard. It just takes you through it, all the mechanics, so the x-axis, so resolution 100 steps per minute, homing speed, etc. So this is pretty much how the default Tronxy come to me. So I've just took the settings out of the EEPROM. I recorded the settings before I flashed this board, plugged them in here. The Z motor is 1600 steps per millimeter. There's lots of settings you can set in here. Yeah, I wanted to enable the settings in here so that when it disabled it, it come across an error with either the extruder heater or temperature sensor, it would kill the print and reset the printer. They weren't enabled by default. So this is enabled in here now. And also I don't think PID was enabled by default. So since I've enabled PID, the temperature control is much better. Although I thought I was doing a PID tune and entering in the PID values, I don't think the default firmware on the X1 used these. So it was dead time control, I believe, and now I've got this set up as PID controller, and the temperature is controlled a lot better. So you just work your way through here. Yeah, the watchdog is what I enabled. And now if the temperature doesn't increase as it should be, it turns it off. If it can't detect the temperature, whether it thinks it's too high or too low, it turns it off, etc. Maybe this won't be completely obvious, but the display controller is a Zone Star P802M with LCD, 20 by 4. and 5 ADC buttons, and the analog button for the analog pin for the buttons is pin 1. And you can disable all the other languages you want. Here you can enter some text which you want on, which comes up on the main screen when it boots, and here you can see how long it's. So this is display it for a second. I think I've actually changed that to 3 seconds just so you can see it when I do that in a minute. So yeah, you work your way through here, and then you get to the end, and you can download the complete firmware. If you've already got 1.0.2 already on there, you can just download the configuration.h file. I must have gone back somewhere here, so somewhere along the line I've switched that to an older firmware, but you obviously do that with 1.0.2, and you can download it there. So I've downloaded that, opened it up in Arduino. Now what you also need to do is the Melzi board acts as it's seen as a Sanguino. So if you go to GitHub, and search for Sanguino, my U key isn't working, so excuse me, I'll just use this. And Lazarus here, Sanguino. So you just go to README. What you do, you just copy this link out, copy link, and then go back to your Arduino IDE, go to File, and go to Preferences. Now down here, Additional Board Manager, all you need to do is create a new line and paste that line in there. And you can see I've already got that in there. And then when you go to Tools, Board Manager, type Sanguino in here, and you'll find it, this one here, and you just want to, I've already got it installed, but you just want to install it. So what we're going to do now, so we want to flash this to Melzi. So we go to Tools. We don't want to send it to the Arduino Uno, so we select Sanguino. The processor for the Melzi board is an Atmega 1284p, 16 megahertz. So we select that one there. The port is, for me, is the same. I'm using the same USB port, so that stays the same. The programmer is Arduino as ISP, and then what we go now, instead of, we don't flash it here because that will try and flash it to our Arduino Uno. You go to Tools, so you go to Sketch, Upload to upload using Programmer, and I'll just turn this around here. There's a light that flashes on my USB Programmer. So it's just going to be going through this, and then hopefully we'll get a programming LED flashing here as well. So let's click that. So it's going to compile first, so you can see it's compiling down here. Now it's uploading, so we've got the serial LED flashing on the USB, and we've got the programming LED on the Arduino Uno flashing. And this takes a little while, so let's just sit and watch this. So this is programming Melzi board. It's quite simple. So once we've done this, so we can do all this without a bootloader. And once we've done it, you can that's fine. You can use it, and you can reflash firmware every time like this if you want. But it makes sense to flash your bootloader, and then we can just plug the USB from the Melzi board straight into a computer and upload the sketch that way. And that way we don't need to take it out of the case to get the ISP header. So let's just be patient and wait for that. It's still uploading. So about halfway through, this LED is still flashing, but about halfway through this LED just stays solid, I've noticed. So don't panic if that LED stops flashing. Okay, so you can see that LED has stopped flashing, it's still on, but it's stopped flashing. But if we look at our USB, the LED, the transmit LED is still flashing there, just in there. So we just be patient, and once it's done, you should see the screen on the Melzi reset. It's still going, takes a little while. Oh, done uploading. Yes, and the Melzi is rebooted. Repetier 1.0.2, Keeps X1. So there we go, we've just flashed stock Melzi board for the Tronxy X1 without a bootloader. So that's okay. You can see it took me a little while to get this set up, particularly as I was trying to do it on the Mega initially, and it just wasn't having it. So I did manage to do it on a another little microcontroller as well, which I can't see at the moment. It was a Tronxy 3.1. That worked as well, but I thought I'd show most people will probably have an Uno, if not like this, a proper Uno board. Just need to wire your 6 wires up and it's fine. So let's admit it though, it is easier with a bootloader. So let's, without changing any settings, if we go to the Tools menu and just select Burn Bootloader, so we've still got Arduino selected here. We've got our Mega 1284 or our 1284P at 16 megahertz. Same USB port, but let's just select Burn Bootloader. So this is quite a bit quicker. So we're programming it, and it's done burning bootloader, it says here. We've still got display on the screen, but if I try resetting the board, there's a reset button here. Nothing happens. So what happens if I just going to pull the power out from the USB here, plug it back in. So now that's basically, we've got no firmware on our Melzi now, it's blank. But we do have a bootloader. So let's try it. So just unplug that. Let's unplug this pin header here. We can get all this out of the way. So I've just got a Melzi board and a standard USB A to B wire. So let's plug that in there. So that's just a USB lead coming out my laptop into the back of the Melzi. You can see there's still no display on there. It's blank. So what do we do now? Well, we've still got our configuration, Arduino open here. So let's change the board from, no, we want to keep Arduino. That stays exactly the same, but our port has changed. That's a different number now. And instead of, we're not going to go to Sketch Upload using Programmer, we're just going to upload it normally. Press the upload button. And again, it should compile. It's compiling. And if all's gone well, it's compiled, it's now uploading. So this time we don't get any flashing lights to indicate it's programming, but the Arduino ID says it's still uploading, so let's be patient. It's done uploading, and there we go. It's rebooted, and we've got our firmware back on there now. Let's just, if you didn't get that, let's reset that. You have Tronxy Repetier 1.0.2 keeps X1. It's all back and working, and we've uploaded that over USB, just connected directly to our laptop. So we now have a bootloader on there, which is a whole lot more easier. And whenever you want to go and reconfigure your laptop, sorry, 3D printer, we can just do it over USB. Hope that was useful. Sorry, I forgot to mention this just now. If when you plug your USB in, your USB lead into the Melzi just before you flash it, and you don't get any screen lighting up, or this LED here isn't lighting up, it's probably because the Melzi board hasn't got any power. There's a jumper here with 3 pins. See, I pulled it out and the screen goes off. So basically, normally you've got your 12 volt coming in here, and then there's a voltage regulator that gives the board the 5 volt it needs to power it. So that pin is normally on the front 2 pins like that. So the 5 volt is powered from the regulator coming off the 12 volt line. If we want to power it with the USB, the 5 volt here, you need to put it on the back 2 pins, and then that will the USB is now powering the board. But before you put the board back in, wire it all up, you need to make sure you put that jumper on the front 2 pins, so that when you plug the 12 volts in here, the board will get power. Otherwise, unless you've got something plugged into a USB, it won't power up. So just be aware of that. If something's not working, and you haven't got 12 volt power in here, make sure it's on the back 2 pins. But in normal operation, you want to make sure it's on the front 2 pins. So just to recap there, we had a Melzi board out of my Tronxy X1. It didn't have a bootloader on it. So we went through the process of, firstly we uploaded the firmware without a bootloader, which you could use that method every time you want to upload the firmware, but it can be awkward as you've got to take the board out of the case and get onto that ISP header. We then, to make it easier for future upgrades, we burnt the bootloader and enabled us to burn future firmware straight onto the Melzi board using the USB from the back of the Melzi into our laptop. So I hope that was useful. Any comments, please leave them below, and yeah, I'll see you soon. Bye.